Hi, in this short tutorial, I will show you how to approach question 3.1 using Stata. So question is the following. So we have 3 fiat coins and we are tossing them 3 times. And we are interested in 3 different events, probabilities of 3 different events. Event A is the event that we are getting at most 1 tail. Event B is the event that we are getting at least 1 tail, and C is the event that we are getting all 3 tails. So we would like to know what are the probabilities of A, B, and C respectively. Let's open up the Stata and let's try to create a program which basically simulates the random numbers and solves the problem. Okay, on the screen you should be able to see the Stata now, package Stata. So we rely on the following program. So we set up, a space for 1 million observations, 1 million simulated data points, and we simulate 3 different random numbers, T1, T2, and T3. So T1 is whether in toss 1 we get 1 or 0. So we set T1 to be 0, and then we replace it by 1 if the run with probability 0.5. So this means that we are replacing that with probability 0.5. So that means that with probability 0.5 we are getting tail, and with probability 0.5 we are getting head. So head T1 would be 0 if the outcome is a head, and T1 would be 1 if the outcome is tail. We do the same for toss 2, so which is indicated here. So we can get 2 possible outcomes, head or tail, with equal probabilities, and we do the same with toss 3. So again, we are getting either head, which is given by represented by number 0, or tail, which is represented by number 1 with equal probabilities. And then we are getting generating new random variable S, which is basically total number of times we are getting tail in this experiment. So what are the possible values for S? We can get either tail exactly 0 times, or exactly once, or exactly twice, or exactly 3 times. And that's it. Those are all possible outcomes. 4 possible outcomes can come. Now, if we tabulate S, we basically run the program and tabulate S, we basically get the frequency table. So we are getting 0 with probability 12.45%. We are getting 1 with probability 37%. We are getting a number of tails equals exactly twice at 37.57%, and we are getting tails at exactly 3 times at 12.51% probability. So now probability of event A would be basically sum of 2 numbers, right? Because S equal 0 and S equal 1 supports event A, so that's why probability of event A would be sum of 12.45% and 30.47%. To get the probability of event B, we need to sum up those 3 numbers, because event S equals 1, S equals 2, and S equals 3 supports event B, and that's why probability of event B would be the probabilities of S equal 1 plus probability of S equal 2 plus probability of S equals 3, okay? And probability of event C would be probability that S equals 3, which is 12.51. So that's one solution. Or alternatively, we can do the following. If we want to avoid these calculations by hand or by paper and pencil, we can basically do the following. So we generate A, so that means whether A occurs. So if A occurs, then we have does not occur, then we have 0. If A occurs, then we have 1. So when A occurs if S is total number of tails at most 1. So that means that S is less or equal to 0. So if S is either 0 or S equals either 1, then we are supportive of the event A. And then we tabulate A. So let's run this small program. So we tabulate now frequency table for A, and we get the probability that A occurs. So A equals 1 is almost 50%, okay, 49.91%. So that basically answers question number 3.1 A to calculate probability of event A. Now, in order to calculate the probability of event B, we do the same. Now, event B is occurring when we are getting at least one tail. So we replace B equals 1 equals B equals 1 if S is more than equal to 1, and we tabulate B, okay? So, and we are getting what? Probability that of B occurring is 87.55, because that's how many times B equals 1 or B occurred basically. And to calculate probability of C, we do the similar task. We generate C being 0 or 1, and C will be 1 if S is exactly 3. Okay, so please make sure that you are putting double equal, so which basically is checking the condition, not assigning value 3, but checking whether S is 0, S is 3 or non-3. And then we tabulate C, okay? So we tabulate C, we get the probability that C occurring is 12.51%. That's basically concludes question 3.1 using Stata. I hope it helps. Thank you very much for your attention.